Hello and welcome to my YouTube channel. Today we're going to be discussing problem 1 from the 2019 AIME exam. Consider the integer n is equal to 9 plus 99 plus 999 plus 9999 and so on up until we get to the integer 9999999 so on with 321 digits. And we want to find the sum of that sequence. Precisely speaking, the sum of the digits of that sequence. So how do we get started? Well, let's just write it down. First of all, writing it down is helpful. And then all the way up to where we have 321 digits here. So what's interesting about this problem right here is that for each integer in the sequence, you can write it as a power of 10 minus 1. So for 9, you can write it as 10 minus 1. 99 can be written, just erase that. 99 can be written as 100 minus 1. And so on, right? So we can represent the sum of the sequence as 10 to the first plus 10 squared plus 10 cubed all the way up to 10 to the 321st power, and minus the number of terms that are in the sequence, because we're only subtracting 1 from each term. So since there's 321 terms in the sequence, we just subtract 321, right? So our integer for n will look something like this. 1, 1, 1, 1, 1, 1, all the way up to the tens place, because that's what we cover, and then a 0 for the ones place. And that 2 minus 321. So what will this look like? Well, we can start subtracting. 0 minus 1 is 9. Cancel the 1. Place it with the 10. We have 8 then. Again, cross out the 1, place it with the 10. We have 7. And then for the 1 next to it, which should be somewhere around here, we can just cross that out, place it with the 0, and that digit will be 0. And the rest of the sequence will be 1s. We just need to find out how many 1s are here. So let's think about that. So in order to figure that out, we first need to figure out how many digits are in this initial term up here. Well, we know that we added 321 powers of 10 to get to this number. And each one represents a power of 10 that we added. So the first digit represents 10 to the 321st power. The second digit represents 10 to the 320th power, and so on until the last one represents 10 to the first power. So we have 321 ones in this number that is underlined in green. But we also have a 0 at the end. So in total, this number has 322 digits. And because this number has 322 digits, this number will also have 322 digits. Because subtracting just 321 won't affect the number of digits that are in the difference. So now that we know that the difference of these two numbers gives us this number right over here, we can figure out how many ones are in this number. And to do that, we can just subtract. We can subtract the digits that aren't ones from the total number of digits. So because we have 4 non-zero digits, we know we have 322 minus 4 is equal to 1. I should correct something I said earlier. We have 4 digits that aren't ones, not non-zero digits. That is my bad. So we have 318 ones, right? And the sum of those digits will just be 318. And now we have to add on the 4 digits we didn't count. So we have to add on the 0, the 7, the 8, and the 9. And when we add these digit sums together, we will get our final answer of 342.